My name is Waldemar Horvat. This is Pascal Luis Perez. And we're going to be talking to you about what's going on with JavaScript language standardization. Pascal has been involved with this for just a short time. I've been on the ECMA committee for longer than Google has been a company. Was involved with standardizing ECMAScript edition 3. I was back at Netscape then. Currently, we're working on ECMAScript edition 4, and this talk will present what we're thinking about.
Okay. So just a little disclaimer. What we're presenting is a process. It's things that have not been standardized yet, and which the committee is working on. So the final language might be different. Some features might not be present. Some semantics are not fully designed. So don't start writing an implementation tomorrow.
There is quite a bit of debate within the group. So some features are controversial. The entire existence of whether JavaScript should evolve at all is also controversial, and there are interesting corporate politics about that, which we will not get into in this talk.
So we'll speak about JavaScript history, just one slide, and then we'll mention the new object-oriented support in the language and what's coming to support this kind of programming in a more easier way. Then we'll touch about static typing and dynamic typing and how this is going to be combined in the new language. Finally, some syntactic sugar and a note about some compatibility quirks.
Yeah, the impetus for doing this is to fix some things with JavaScript and also to provide better support for programming in the large, which is constructing scripts out of constructing libraries for scripts, constructing scripts out of components which are not necessarily trusted with each other, providing some safety invariance. So, for example, you can have something which is private to your class, and the language will guarantee you that nobody else can get at it. It will not solve all problems. ECMAScript edition 4 is not intended to address the dumb incompatibilities. This is outside of the group's charter. So, but it does provide a foundation on which we hope to be able to build the next generation of web applications.
Do you want to touch on
so the JavaScript, which was originally called LiveScript, was invented by Brendan Eich at Netscape back in '96. It was a Netscape product for a while. Other companies, such as Microsoft, made a clone of it called JScript. The implementation was the spec in the early days, so bugs in the implementation were copied into other implementations. Eventually, a bunch of companies got together and under inside the ECMA organization and standardized JavaScript. Due to trademark issues, we couldn't use the name JavaScript for a standard, so it was called ECMAScript instead, to try to find a name which was as unattractive as possible. So I've been involved with this since 1998. I wrote parts of the third edition of ECMAScript standard, which is both an ECMA and an ISO standard. And since about '99, we've been working on ECMAScript edition 4 in various guises. Google just joined ECMA last month. So this is new to Google, but I've been involved with this in other contexts.
So some of the design goals of the new ECMAScript 4 is support for object orientation. Lots of web apps out there are very object-oriented, and having that built into the language makes things way easier and makes interactions between two libraries easier. Some stronger static guarantees, static typing, And this is built into the language, and there's a type system that is being developed to mix the old world, the legacy world, with the new statically typed world. And there's definitely a willingness to make both work together very well. Having more room for performance is also a key thing in the standard. Lots of time is spent on trying to make new features of the language simple enough so that very simple implementations can still be out there. And finally, being compatible with ECMAScript, except some really weird corner cases.
Now, the old world is a dynamic world, but that is not going away. We're not deprecating it. ECMAScript will remain very much a dynamic language, and we're evolving both sides of the language forward. So one of the first things we're adding is support for block scoping. Over here, if you're familiar with how JavaScript works right now, local variables, even with deep within a function, are hoisted to the top of the function. So this variable declaration of b actually takes effect at the top of the function. So b is a local variable. One interesting feature, you could call it a bug of ECMAScript, is if you don't declare a variable, it's global. It creates a global dynamically. We'll address some of this in a thing called strict mode, but of course it has to remain the same for backwards compatibility. There is a new construct called let, which instead of hoisting it to the top of the function, will hoist it to the top of a block. So this declaration of D would take effect here. Now there's some controversy and debate within the group about whether let should hoist at all, or whether it should behave like in C++ and Java and just take effect starting from here. We're also adding const, which declares things which you cannot mutate after you've defined them.
And this is also the source of many debates about
there's quite a bit of debate about what const should do.
What constancy is.
Yes? Well, constants, final in Java is very different from what const in C++ is. In C++, const means one of two different things. One is, depending on where you use it, it can mean that you cannot mutate it, but somebody else can. It can also mean that nobody can mutate it. What I hope we achieve here is that const will indicate that anybody who's able to read the value twice is guaranteed to see the same value. So so once you set the value of a const, you will not be able to change it. Now there may be situations in which you can access value before it's been set, and we're arguing about what should happen then. It's probably going to be an exception.
Am I correct that in the current, some of the browsers now support const?
Yes,
in a very weird way.
Some of the features of ECMAScript Edition 4 are already implemented in Firefox in JavaScript 1.7. So this will not be, in terms of release, I don't expect this to be an all-out, release where suddenly you have all of this stuff. It will be released incrementally, and some of it is already there.
So, but with regard to const, so in some of those browsers, you can read a const variable twice, and you may get two different values.
So that's one of the disadvantages of releasing things, as we're kind of working on them, in that we may change our mind. So some of this intermediate behavior may change. So there are So to introduce block scoping, we do this via a let statement. There are actually 3 forms of it in ECMAScript edition 3. It's also slightly controversial as to why there are 3. This one here.
Did you mean ECMAScript 4?
Oh, sorry, yeah, ECMAScript 4. Yeah. This one here creates a block local variable A. This one lets you have bind a variable just for the scope of a sub-expression. So you can use this form inside expressions, and within the sub-expression after the let, A is set to x plus y. And this form lets you do the same thing for statements.
So one feature that's already present in Firefox 2 is destructuring patterns, where you can have some patterns on assignments, and the language basically does the destructuring that is required for you. So you can write nice things like the swap function, which reverses in a very clean way, and reading the function, you see exactly what's going to happen.
Yeah, just the square brackets mean arrays in ECMAScript. If you're not familiar with what it is in edition 3, curly brackets means objects of named properties.
And now we come to the object-oriented features, classes. So ECMAScript has dynamic classes, which are really the same thing as ECMAScript 3 objects. It just provides a nicer syntax. You can have fields and extend them, add some, and you can also have Java kind of classes where if you remove the dynamic keyword, then this class is in a way sealed. There's nothing that can mutate the number of fields on this class.
Yeah. So the dynamic word does not mean final like it is in Java. What it does mean is that if you create an instance of this class, if the class is dynamic, you can add additional properties just like you can add them to ECMAScript objects now. If you do not say dynamic, then the fields that the class declares are it. You can still subclass, and in the subclasses you can add new ones, but once you have an instance of the class, you cannot create more of them ad hoc at runtime.
There's also interface, which are exactly the same as in Java, basically. You can define a set of functions that need to be there, and when you implement it, you need to have that to pass the implementation.
Yes.
There's also this notion of generic functions, which, based on the type of the parameters, selects for you at runtime a function.
So these are for global and static functions only. We do not have plans to support this for instance methods, just because combining this with semantics of overriding gets weird.
And there's this concept of, yes, sorry.
On generic functions, are these outside the encapsulation boundary of the objects they operate on?
They are just global functions. So you can declare a global function as generic, and then you can incrementally add new sort of overloads of it from different places. So it's probably would not make a good secure security boundary, since there is no way to close it.
Namespaces are a way to protect names. So instead of having just one name, you can have a tuple, namespace plus name.
Yeah. Namespaces are the key provision for programming in the large, where if you're getting scripts and libraries from various places, if you publish a library and want to evolve its API, you need to be able to create names without conflicting with names that somebody might have used in the client program.
And this is also how ECMAScript 4 is going to support private and public things in classes. Basically, when you create a class, you get for free 2 new namespaces, which are one name private and the other public, which no one else but you can refer to. And this allows you to make the distinction between visibilities of your fields and methods.
However, unlike in Java, You can also create other namespaces which can function like public and like private. So you can have various degrees of privacy simply by not giving out references to the namespace. And so we've been debating, how to make this reasonably secure. And it has implications on things like iteration through properties, but which I won't get into. But we're trying. We have as a goal the ability to make various degrees of access available and worthwhile to use.
And just like Valdemar said about programming in the large, namespaces also give a way to evolve APIs by protecting each method by a version number. And basically, people can use a service based on a version number, and it'll select which kind of method you have so that you're not bound by old APIs to develop new ones.
Yeah. Now, version 1 and version 2 are namespaces here.
There's also the notion of a package, which is basically some functionality that's split across multiple files and has got a name. And just like classes, packages create for free two namespaces, an internal and public one. So you can have in one file a field defined that's internal, in the other a method that's public that uses this field. And when you run your code, you can import this package. You can use the method, but not access the field, which is internal.
So is the execution model still going to be that logically all the source files are concatenated into one long string of source and then evaluated?
So far, until we get to the next slide.
Okay.
So you've got this notion of program units, which are exactly what you said. Basically, different programs in different files. And a program unit can provide some functionality by requiring some functionality of other program units. So for instance, you could have a Google Maps mashup, which allows you to draw on maps. And to provide this drawing functionality, it needs the Google API. So you have a unit, draw nerve, and it uses another unit. And for the moment,
there's a double quote missing there.
Yes. Yes. For the moment, you can also give a URL. And the thinking is browsers will download units automatically, but this is not finalized yet.
Yeah. Now, the standard ECMAScript standard will not say what the format of this string is. In browsers, it might be a URL. In other applications, it might be something else. But this will be set by the embedding.
So now we come to the typing part of this talk about how static typing and dynamic typing are going to be merged into one type system. So historically, JavaScript is dynamically typed, and there's basically no notion of types. So the language is being expanded to allow type annotations. For instance, this var colon int specifies that I can only hold an int throughout its life. And the unannotated code has some special star type, which is compatible with everyone. So types are introduced by language construct, just like in Java or C++. Classes introduce the name of the classes introduce a new type. They can also be constructed from others. There's this notion of union types and notion of record types.
Union types are not like C++ unions. It's more like ML unions, where you can create a union of something which can be of type A or type B or type C. They're not tagged.
Yeah, I guess if you look in what the values of this type represent, is basically the intersection, the union of all the values of string and all the values of int combined.
A record type is just like what you have in ECMAScript edition 3, except that we now have a name for values with a property called name, whose value is a string, and a property called age, whose value is an unsigned integer.
And you can also alias names. So you say type point equals this. And whenever you refer to point, you're actually referring to the short name. And it's not attaching any brand to it. So it's really just an alias.
So type def.
Using the union types, there's this notion of nullability and optionality. Values can incorporate nulls or not. And null is actually a distinct type from all the other types. And this allows to express things like this value will never contain the value null, or this field is never going to contain the value undefined. And there's some shorthand, some syntactic sugar to express that easily. T and the question mark says this version is nullable, and the other one says that it's non-nullable. And there are some defaults. The numbers, all the numbers types and booleans are non-nullable by default, and all the others are nullable. So the two syntax are useful.
So value of type numbers is non-nullable by default, but if you say number question mark, you can stick null in there. Similarly, if you define your own class, it is nullable by default, but if you say your class bang, you can take the null out of the type.
Is this simply just for backward compatibility with what is expected right now?
Not really. It's
Yeah, I guess it doesn't really.
yeah.
Well, I guess it provides two kind of notions.
It's useful to be able to express whether null is a legal value or not, and
I mean,
that depends really very much on what you're doing.
The difference in the defaults.
The difference in the defaults, it's kind of similar to what Java does, and for string we actually have. If you're familiar with JavaScript, currently it has string and string wrappers. We actually have 3 string classes. We have a lowercase string, which is just a string, non-nullable. We have the uppercase string, which is the current string wrapper, which is kind of fairly useless and very confusing to people. And so then we have a third class, which is the union of the two, which is like any string. And that one is just for backwards compatibility. If we were starting afresh, we would just have lowercase string.
And there's also the way to say whether a parameter type is optional. So you can say t equals, it's kind of in the corner there, and this will mean that this parameter type is optional, and it can only appear in functional types, which we'll get to on the next slide.
In function signatures.
So here are just some examples. Boolean, question mark, you can put null. Int equals null is an error because it doesn't include null. The date object can be nullable. And here's an example of a functional type with an optional integer parameter. So functional type are there to give information about higher order functions that are being passed in a function. And they're kind of like standard functional types. The only 2 additions are a support for variable length argument, which is exactly the same as what Java has, the 3 dots in Java. And since functions can be used as constructors, there needs to be a way in the syntax to be able to tell to the type system what kind of expression you get when you instantiate this function. So you can say this, and this function is going to create a Boolean.
Parametrized types are just like generics in C++ or Java. The syntax is ever so slightly different. You have a dot before the opening and less than to cut down on some of the grammatic ambiguities. You can type def generic or parameterized type. The map of key and values should be familiar to all of you from other languages. It's just a hash table. You can define your own classes, which are also generic, parameterized by types or generic in types, and you can use generics in kind of the obvious ways.
Yeah.
What is the type of a generic function?
So the question was, what is the type of a generic function?
It's when you declare a generic function, you must. The first thing you must say is, the generic function declaration, which says generic function, and give it a parameter list. Every instance, every overload of this function must have parameter types which are subtypes of the initial definition. So I would assume that the type of a generic function is the initial definition. It might not resolve if you call it with some arguments, combinations, but that would be the logical type for it.
Are there parameterized functions? For example, is it possible to provide a function that takes any key or returns the same type?
Yeah, you can,
yes,
you can put a dot.
Yes, you can have parameterized classes and parameterized functions.
What's the type of parameterized function?
You must instantiate it with a type to get a function of a specific type. I don't know how far up the type metal hierarchy we want to go.
Then to combine old features with new features, there's like and wrap.
So this is for the Valley script variant of ECMAScript.
So like types provide a precondition. So if you say that a variable is of like type int, then it's going to be like an int, but just at one point in time. It doesn't give any guarantee on the evolution of this variable. So it's useful if you want to have some API that talks with legacy code. You've got some precondition on entry to the function, but you've got no guarantees on the evolution. The wrap, on the other hand, does a precondition check and then adds an object around the value so that it can prove that the evolution of this variable is going to follow the wrapped type.
So like is, when you have a like parameter in, let's say you say like string in a function, the function will allow various things which kind of in current ECMAScript behave like strings, and they will pass them through unmolested to the function. If you say wrap string, then it will still allow the same set of things, but it will coerce them at the point of entry to the function into into the type that you said. So it's kind of a coercion operator.
Yeah, there we go. So like is this precondition, and compared to pseudo Java, it's basically doing an instance of check before, and since data is not nullable, we're also checking for not nullability. So nothing fancy.
So
some more syntactic.
Yes.
Are you saying without the like operator, the types will actually be checked for runtime?
The types are checked. The question is, without the like operator, what happens if you don't declare, you put types on your parameters, then it's anything goes. If you do put that type on your parameter, then the language is much stricter about what you can pass in there. So like is a way of relaxing some of this strictness to allow similar looking things, and where similar looking things is defined by the language to get accepted.
So I guess putting just the type in there is the strictest, and then like is a little more flexible, and wrap is really flexible.
Well, wrap is just like, except that it will coerce. So it will convert the value into the type.
So now, some more syntactic sugar. The foreign construct now don't enumerate all properties, but objects can be iteratables and produce an iterator so that they can protect some of their properties or give some consistent view of how you can iterate over them.
So we're providing, in edition 3, for in always iterates over the properties. And here we're introducing an iteration framework so individual classes can define, or you can define your own iterator kinds.
And the for each is really standard, just syntax. There's also this.
So the generator is how you define the iterator framework.
Yeah. So basically, there's a new keyword yield, which produces a temporary return, creates a new iterator. So what this code would produce is an infinite number of numbers, starting at 0.
I mean, these things have been around for a long time in non-mainstream languages.
Well, Python has generators.
Yeah.
Yeah. Python
Yeah.
has.
Okay. I guess Python has them too. So there are miscellaneous cleanups we did the standard will require implementations to be tail recursive under specific conditions where it makes sense. We'll have expression closures, so a function, if you define a local lambda like here, it doesn't need to contain a statement. You can just put an expression in there, and what it means is as though you had said open brace return x times x, close brace. We also have array comprehensions, which are a way of generating an array from a generating expression. So probably the most reported bugs in to the browser vendors, I mean, at least Mozilla, are the arithmetic. People complaining that the arithmetic is broken. They do things like call toFixed on a number and complain that it rounds the wrong way, or complain that's 14.28 times 9. It gives you 128.51 and a whole bunch of 9s. And that this is actually mandated by the standard. The standard says that you shall follow IEEE 754 arithmetic, and that is what IEEE 754 arithmetic does. That's not what people expect, and this has been a thorn in our side for a long time. So in edition 4, we will also support the upcoming IEEE 754R standard, which uses base 10 arithmetic instead of base 2 for floating point numbers. And so this will be, you'll be able to enable this locally on within a scope by using a pragma. So we'll have two types of numbers, two types of floating point numbers, the good old IEEE doubles, and we'll also have the decimal floating point numbers.
So
Yes?
the Java approach to that is just to create a class big decimal
Yes?
and use that instead.
Uh-huh.
Did you guys consider that? And what
Yes,
is
we considered this. I mean, we've been arguing about this for years.
Oh, okay.
This was on the table, but it was not well liked as a solution. So there are various library additions, some controversial, some not. The map class is essentially a hash table without exception. Well, you could say that current objects are hash tables, but not quite. They have some specially named properties, and which can cause trouble if you try to set them. So we're introducing a dense typed non-resizable vector class. There is a proposal for an optional stack walking library. It would only walk with frames which you are explicitly annotated. It wouldn't let you pick at all of them. This is that's also debatable. Some of us like it, some of us don't.
And the strict mode will be this mode where you get type checking and static analysis that checks for various things, calling functions, assigning to non-existent variable, redefining a const, things like that.
So, well, just to clarify, you get type checking always. So if you say if your expression has a type, then you always get the type check. But this, there are things in edition 3 which we must retain for compatibility, such as and these things include, well, if you misspell a local variable in your program, you suddenly create a global out of thin air. And so strict mode is designed to warn about things like that. If a program passes strict mode, then it will behave exactly the same way as though you didn't use strict mode. So it does not change what the statements do, other than giving you static warnings. There's one exception to this, which that is if you use eval, then strict mode there are some interactions between eval and strict mode, which are beyond the scope of this talk. Yes?
With statements.
Yes?
With statement, inside the with statement, you declare a variable and initialize it. The variable that you initialize may not be the one that you declare.
Yes, that's a very fun one.
Whether there's a property in the with statement,
yeah.
say name or not.
Yeah.
Is this addressed or is it not addressed?
I wish I could get rid of with statements. I mean, they are an abomination in edition 3. No, I cannot for compatibility. However, we did one thing which might address some of this, and that is we introduced the concept of a typed with statement, which is you give in the with statement you will be able to give an expression and a type, and the type. The implementation will then see the type. It will know what the properties of the objects are statically, so it will be able to detect things like that. Yes?
So I don't understand the design constraints. Once you have the use strict pragma, what you're saying is in presence of the use strict pragma, you can turn off things that would work in ECMAScript 3 but that are considered a bug.
Oh.
Why can't you just simply consider with as a whole to be a bug in ECMAScript 3 that's turned off by the use strict pragma?
Well, that's one possibility. So, I don't think we'll go there, but this is something that to be considered is whether use strict should turn off with and eval. Now, there are some legitimate uses for these things, although I'm not in favor of an untyped with.
Are you in favor of a typed with?
A typed with is much less harmful because you can look at the type and see what bindings you're introducing statically. We can debate whether it's good programming practice or not, and various people on the committee have different views about it. I really, personally, I don't see much of an advantage of it. But.
Then, last point about compatibility. Some little things that changed in ECMAScript 4 that were valid in ECMAScript 3. Redefining the native values of the language, like redefining undefined, then alert will spit out 4 instead of undefined. There was also some keywords which are being reserved. So if you're saying that your program is an ECMAScript 4 program using some mim type or some global value, then this code will not work, whereas it would work in ECMAScript 4.
Yes, for keywords, we had this debate a long time ago. And, it is possible to define a new language without introducing any new keywords. It's not going to be pretty, and it would be very confusing because you need to use punctuation for various language features, and we decided that it would just be too ugly to be usable, so we are introducing several new keywords in ECMAScript edition 4. So what that means is out on the web, if you have an edition 4 script, you must use a MIME type or some other metadata to tag it as edition 4, otherwise the browser will think it's edition 3.
And can edition 3 scripts and edition 4 scripts coexist on the same web page?
Yes. Yes, and in fact, I think one of them will be able to eval scripts of the other kind and vice versa. And there's quite a bit of fun you can have that. The question was, can edition 3 and edition 4 scripts coexist on the same web page? And the answer is yes.
I guess the last quirk is a removal of a bug that two regex, the same regex in the same place in the program is the same object. So this code produces true and false in ES3, but true and true in ES4, which is basically what you would expect.
So this, it's a little contentious. Now this is called a bug, where if you have a regular in ECMAScript, it's unfortunate, but regular expression objects or literals have mutable properties, and these mutable properties include such as if you're doing a global search, and then where along the string are you at? So when you parse an edition 3 program, whenever you see a / regular expression literal, that creates a particular object. And it creates that object once, and only once. So if you reach the same place in the source code again, you'll get the same object, which has this mutable property. Now, this was actually not a bug. This was intentional in edition 3, but now they're thinking of doing it the other way, where each time you evaluate it, you get a different, separate regular expression object. And so this is also slightly controversial.
Okay, thanks.
So
yes.
Why is it not a bug? Why was it not a bug?
Well, I was there when it happened the first time around. It was intentional, so you would avoid having to create lots of objects. Yes?
What about class inheritance? Will there be single inheritance?
Okay, the question is, what's the inheritance model? It's single inheritance, very similar to Java.
Multiple inheritance.
So you can have multiple interfaces, single class inheritance.
Yep.
Yes?
Do you think there's going to be any kind of performance degradations solely with checking?
Okay, the question is, what are the performance implications of edition 4? The goal is to have performance which is as good or better than before. And we are introducing things like vector types, some integer types, and so on, which will allow an implementation to perform better than existing ECMAScript on some classes of programs. Now, you will probably be able to find some programs which might be slower than before. I don't know of any important classes of applications which fall into that category where you would actually care. But there is nothing in the language I'm aware of which would make it needlessly slow. Yes?
The integers, are they unlimited precision?
The question is, are the integers unlimited precision? It's open to slight debate. The current thinking is no, we will have 32-bit integers. I was hoping to at least get 64-bit integers in there too. The difficulties you run into is if you what is, if you have a constant 15, it's currently, thought of as a double. So if you had an unlimited precision integer and added 15 to it, you'd add an integer to a double, you'd get a double out. Things get very confusing very quickly.
So what happens when you overflow 32 bits?
So for integers, it's as though you were doing the arithmetic as doubles, I believe. And that's, there is really, given the addition 3 semantics, there is no good solution to this that I can think of. You can optimize for one thing and then the other thing will screw you, or you can optimize for B and then A will screw you. Yes?
So let's say I have a piece of ES4 that imports a module that defines class employee, for example.
Yes.
And then somewhere in there, I eval a piece of code that internally imports that same module defining class employee, creates an instance of employee, and returns it. And then I get the return value of that eval.
Mm-hmm.
Does that return value match as an instance of the employee that I've imported? In other words, is there an inter-VM notion of type that's bound to where the code came from and some unique identifier of the type?
Yes, if you import a unit, then you'll get one copy of the employee class. So, and the instances, will be instances of that class, and so you will not have separate employee classes running around the system.
Okay.
Now, if you just start evaluating things, it's as though you had, multiple definitions of something in your object. So, if you define a class twice, you'll get an error.
Right. No, but in the eval code, I imported.
Yeah. If you import a unit, then you'll, I believe you'll get the same one. So.
Okay. All right.
Yes. Okay, the question is, when will browsers start supporting this, and is it available internally? So some parts of this are already supported by Firefox today. To get a hold of, there is a reference implementation, which you can get from ECMAScript.org, and we have a local copy of it within Google, so you can play with. The reference implementation, curiously enough, is written in standard ML, and it's to help us. So the reference implementation is built for, is optimized for being a good semantic match to the spec. So it's to help us with spec writing rather than to try to be particularly efficient or a guide to how somebody would implement this in practice.
There's been, I don't want to speak for Microsoft, but I've heard that they won't push it in IE7 for sure, maybe IE8. And there's some debate as to whether ECMAScript 4 will make it in an IE browser at all. Yeah,
now the companies heavily involved in this are Adobe, Opera is there, and Mozilla is there. So there will be, I expect, I can't really speak for them, but I expect that there will be some implementations of this soon after it gets adopted. Yes?
So is there also a group working on solving what I think is the real problem with JavaScript, which is the dumping compatibilities between different browsers?
The question is who is working on solving the real problem, which is the DOM? Okay, I agree this is the real problem, and we're not working on it. You're welcome to start something if you like. The politics will be quite brutal.
without breaking in the normal browser.
Okay, how will, the question is, how will applications writers take advantage of this? Well, I mean, if you know what browser you're running in, then you can serve an application optimized for that browser. Well, if you don't know, well, I mean, you can try to detect somehow. You can, go for the least common denominator. If you're in,
have to code base.
If you're in places like cell phones, you might know quite a bit about what you're running on.
But there's no latent detection of this every form. Like you have to detect when you say agent and it's
So there will be fairly simple and blessed ways of detecting what kind of implementation you're running under. There's a second question you might ask, which is, what would an implementer do? Would he have an ECMAScript edition 3 engine here and an edition 4 engine here? I would expect not. You could do it that way. I would expect there to be just a single engine which understands the edition 4 syntax and has a mode in which it understands the edition 3 syntax. Yes?
So I have a sort of question or comment, perhaps it's more philosophical in nature. So this seems to be a rather large extension to the existing language.
Yes?
And it's bound to have several implementations from different companies probably that are probably having mistakes, little mistakes here and there. And so there will be different kind of same standards evolving over time. And so when you are a browser, when you are a company that implements a browser or implement JavaScript or something like that, you probably want to accept as much as you can because you want to be lenient, because the more you can show, the better you are. So everything that goes on the web, at some point, deteriorates to the lowest common denominator in some ways. And so it's going to get even larger and even more complicated in some sense. And I'm wondering what the kind of thinking is behind the general sort of philosophy behind the evolution of this language, because it's going to get very, very, very large and very, very complex over time. And I would think if I were to design a language, I would try to make it as simple and as strict as possible and just rely and just make sure that this is it.
Yes, so you have a very important point. Just to repeat for our audience, the comment you made is that this is a complex system, and various implementations may interpret this differently, and a standard may allow some wiggle room. So, and an implementers have incentive to be as permissive as possible to allow mistakes and so on, and still make sense out of them, so at least you can render the web page. Well, that's yes, there is a lot of this pressure, and this pressure has, in things like HTML and CSS, this kind of pressure has caused the mess on the web that we're in right now. So personally, I think that things ought to be spelled out and ought to be written down and as strict as possible where it makes sense. So now, what are the choices for the evolution of a language? Well, there are several. I mean, you could not do things like this joint work and have each implementation kind of play around with extensions and hope to get someplace. And I claim that you'd have more divergence if you did that. So this work is beneficial to that extent. And for features, for specific features, we have debates about how strict should the implementation be. I mean, like we just had one recently about what happens if you have a let variable and access it before it's defined, should that implementation be permissive and sometimes let you do that, or should it be required to give you an error? So these are the kinds of decisions we're facing, and we're very much aware that getting these wrong will lead to the kind of mess that you described.
Okay.
So any other questions? Okay, thank you.
Thanks.